Hello guys, in this video we're going to look at proof. So question 1. Prove algebraically that the sum of any two consecutive integers is always an odd number. So it can be any two consecutive numbers. So any number can be n, but the next number has to be n plus 1. So it's going to be the sum. So it's going to be the sum of n plus 1. This is any number, and this is that number plus 1. So if we simplify that, n plus 1 equals 2n plus 1. Well, 2n is always even, which means 2n plus 1 always odd. So that's proof. Okay, so look at question 2. Prove algebraically that the sum of any three consecutive even integers is always a multiple of 6. So sum of any three consecutive even numbers. So first you're going to get 2n, because that's going to be even. Doesn't matter what n is, two of them is even. The next one, the next consecutive even integer will be 2n plus 2. And then the next one after that will be 2n plus 4. Just goes up by 2. So there's 2n plus 2 plus 4. So if we simplify that, you're going to get 2n plus 2n plus 2n, which is 6n plus the 2 plus the 4 is plus 6. So we've got 6n plus 6. Now we can factor this. So 6 is a factor of both. So we can take the 6 out. So this equals 6 times n plus 1. So it doesn't matter what n is, it's always going to be a factor of 6. A multiple of 6, sorry. Okay. Question 3. Prove that 3n plus 1 squared minus 3n minus 1 squared is always a multiple of 12 for all positive integer values of n. So let's look at this. So we have 3n plus 1 squared minus 3n minus 1 squared. So let's expand these brackets. If we expand this one, we're going to get 3n times 3n, which makes 9n squared. We're going to get 1 times 3n twice, which makes that 6n. So we've got plus 6n. Plus 1 times 1 is just 1. And then we've got, again, 3n squared is going to be 9n squared minus 6n. And then, so this is like this. And then we've got minus 1 times minus 1 is plus 1. Don't forget to keep this bracket here, because where we've got a minus here, we're going to get two minuses together to make the plus. So we get rid of these brackets. It's going to be 9n squared plus 6n plus 1 minus 9n squared. Because we've got minus, it's going to be positive 6n. Minus and a positive is minus 1. So we see here 9n squared minus 9n squared. So they cancel. So this and this cancel. 6n plus 6n, it's going to be 12n. 1 minus 1, they cancel. So we are left with 12n. So here is always a multiple of 12. So you can see 12n is a multiple of 12. We'll do one more. Number 4. N is an integer. Prove algebraically that the sum of n times n plus 1 and n plus 1 is always a square number. So we've got n times n plus 1, and so the sum, so that plus n plus 1 is a square number. So n times n is going to be n squared plus n plus 1. So that's n squared plus 2n plus 1. So this is going to be, we're going to get n plus 1 squared, because it's n plus 1 times n plus 1. If you've got another n plus 1 here, you get n squared. You're going to get two lots of 1 times n to make the 2n. You're going to get 1 times 1 is 1. So this is n plus 1 squared, which means it's any number. It's always going to be a square number. Okay. Hope that helped, guys. Sorry about my nasal. I've got a bit of a cold. Yeah, any questions, let me know in the comments. Thank you. See you in the next video.